production possibilities, right? Production possibilities are simply all the things that you can make. And then we get basically summarize the production possibilities of like yellow as being, well, yellow could, if they wanted to, they can produce 300 A's, or they can produce 900 B's, or they can produce something in between. Which means, by the way, what that means is they could do half and half, right? So you can spend half of the resources, half the people or water or whatever it is, half the people's time, half the energy and all that stuff in yellow to make 150A. And if you did that, you'd still have enough resources left over to go ahead and do half of this number of B's, which would be, by hasty calculation, 450, right? So you could do 150 and 450, and that would be an and, not an or. This is an or. It's either do one or you do the other. But if you wanted to do a combination, you could also work out combinations. Part of the reason why we present the production possibilities this way is because it takes up less space and it implies the other. The other, the more precise and the more like by number, is implied by this. So bear that in mind, that this is really basically a summary of a table that we can make, a much bigger table we want. 300A or 900B. Well, those are the two extremes, but the possibilities from that would be, okay, so if you want to make it like ands, you could produce 300A, and if you're doing no B, right? Also turns out, you can get a word for it, if you wanted to produce 299A, you would also be able to produce 3B with it. So that's a combination that you could have. Another is 298A, and with it you would get 6B. 200B, and so on. So the ands come out of the ors. In other words, if you know the two extremes, then you can make up you can figure out a table with all the production possibilities, which are all the combinations, all the way down to 900B and 0A, because that's another combination you could make. So that would be a whole table like that would at least take up 301 lines. But notice I'm not showing every single one increment of the B. I'm only showing single increments of A on this table. So if I wanted to make a table that showed every possible 1 unit increment of B, that is every single possible way of getting 1B or 2Bs in addition to 3Bs, and 4Bs and 5Bs, and not just 6Bs. If I wanted to show that, this table would have 901 lines on it. And so obviously, I hope it's obvious, but we've chosen to just say, since this individual combinations that you could possibly derive, well, let's just do the one in the box and as a representation of the production possibilities. But bear in mind when you're doing this that the whole table is implied. And the whole table is implied is important because if you wanted to, for example, we did this last time, if you wanted to add A, right? If you want to add 1A, this tells you how many B's you have to give up, right? The whole table would tell us how many B's we have to give up. Like here, you have to give up 3 B's. Right? That difference from 3 B's to 0 is you're losing 3 B's in order to pick up that 1A. And so having the concept of the table at least is good. But it takes up so much space that we don't do it that way. So it helps if you kind of think of it that way, that's really what's going on. What we could do instead is we could say, all right, the 300 A's or 900 B's, in addition to implying this whole table, also implies that since this is an or here, uh, if you made the 300A, it would cost you 900 Bs that you'd have to give up. And if you way, because you can't have both of them, you can have one or the other. If you think of it that way, then it makes it a little bit simpler because then, okay, well now I know, what I'm giving up if I get the only problem I don't want 300 A's if I just want 1A, then this margin, this is like marginal cost. The marginal cost of 300 A's is given 900 A's. But the thing is, the margin, because that's the opportunity cost, right? Opportunity cost, give up. The margin is too big for us. We don't want a margin that big. So what we do is we work on getting the margin to manageable size by, if we make this into just one, then we have to divide this by, and then we may as well divide this side by 300. There. If you divide one side by something, you have to divide the other side by something. So you have a basic algebra thing there. And so you got that 1A, the marginal cost of 1A, 900 divided B's, which is what we found. We did the table version of it, right? So then it's out that you get the same answer. So that makes it kind of good. It also, as long as you get used to the idea that you're making the margin smaller, that's why you're dividing. Margin still means difference, still means change. Hey, I'm going to get a change of 300 A's I didn't have before. I got to give them 900 B's. Well, that's really the change, but if we don't want the change to be that big, we're dividing the change up into smaller bits, which is why we're divided by the 300. So that's the principle that we went over last time. Now, let me go back to handout thing here. Which again, start off with the same. We started off with the same, or the region it is, region, whatever. And on this one, we already know, because I basically kind of told you that, right? 1A costs 3B. We worked that out, right? Suppose, though, we wanted to make 1B. Does somebody want to tell me, using the numbers on this table in yellow, if we wanted to make just 1B, how much would 1B cost to make just 1B? Is it 0.33, 1/3 of an A, right? It's always in terms of A's. If you want to be technical, you keep on going, right? But so it's 1/3 of an A. How you get that is you say, all right, 900 B's cost us 300 A's. If I divide this by 900 to get down to 1B, I'm taking 300 A's, dividing it by 900. 300 divided by 900 is 1/3, or 0.3333. So you can do it on a calculator, or you can do it, just keep it as fractions. But hopefully that makes some sense. Because again, the reason why we're dividing by the 900 is we don't want that many B's. And so we're kind of dividing up the recipe, if you will. Dividing up the margin into just 1B. Now, we got another country or region here called green, and in green, region of country, whatever it is, it turns out that they could make, if they did nothing but make A, they could make 200A. On the other hand, if they did nothing but make B, they could make 800B. So just get used to the production possibilities being presented to you in terms of the two streams that you could do. The implication is, though, that you could also do everything else in between. So from this, if 200 A's basically cost you 800 B's you could be making, if you divide this by 200, you get 1A. If you divide this by 200, you get 800 divided by 200 is 4 B's. And so that's why it says here, 1A costs 4 B's. That's already been filled in. Does that make sense? Anybody want to tell me how much 1B costs if green is making it? 0.25, right? Because it's 1/4. So you basically do it the same way. You say, all right, if you can make, if 800 Bs would cost you 200 As, well, to find out how much one bee costs, you divide that by 800. You divide this by 800, you get 200 divided by 800 is 1/4, which is 0.25. Very good. We got another producer here as well, purple. Purple can make 100 A's or 200 B's. And so if you want to find out the cost of making 1A, you divide this by 100 because that's two margins. So to make the margin smaller, you're dividing by the amount you're getting of the thing you want to find the cost of. If you're getting more than you want of it, you're getting more than one of it, then you divide by whatever number you are getting, and that'll tell you the cost of one, right? But if you're dividing this by 100, you have to divide this by 100. So you take 200 divided by 100, you get 2. So 1A costs 2B in purple. Hopefully that makes some sense. You gave yourself an extra point, right, Omar? Somebody else wanted to tell me how much 1B costs. 1B is David? I'm sorry, Eric. Eric. 0.5. So I can't use an excuse that somebody sits in the same, but there's somebody in my other class who looks kind of like you, so I'm sorry. Okay, so that's 0.5, right? Does that make sense? Now, I have for you handouts that have that. Handouts are question. And you're part of this for studying. But I want questions. There's questions. Yeah. And let me just go over them with you real fast here. They're up here. You see the information on those tables up there. Um, which producer has a comparative advantage in making A? So you kind of have to know what comparative advantage means, right? Just to give you a hint, comparative advantage means you got the cost, right? So all you got to do there for that answer is either tell me Y or G or P. Just the names are yellow, green, and purple. So give me the initial, the one that has the lowest cost of making A. Question number 2: which producer has a comparative advantage in making B? And again, that's just Y or G or P. Question 3: which producer, Y or G or P, has an absolute advantage in making A? Remember, there's a different kind of advantage there where you have absolute advantage. Question number 4: which producer, Y or G or P, has an absolute advantage in making B? Question 5: which producer, Y or G or P, would specialize in making A? Question 6: which producer, Y or G or P, would specialize in making B? We talked about specialization a little bit, I think, last time, but you should know what that is from the book, hopefully. Specialization is when you concentrate on producing something, right? The rest of the questions refer to what would happen if you, for example, were like the king or queen of a country, where all three of these are regions in your country, and you're going to use these three parts of your country to make either A or B for your people, right? And you probably need some A and some B for your people. And so, what would you do? You're going to use the uh, resources, these regions, together in an efficient way. So, how do you do that? That's the question. So these are not multiple choice questions after number 6. Number 6 up to number 6, they're just multiple choice basically. The seventh question is a little bit difficult, so I'm just gonna read it to you, but then you probably have to do it later after you do the first 6. If you want to make 400 A's, can you figure out the most efficient way of doing that? And kind of the test of whether you're getting the most that you could get, which is what efficiency means, right? Is are you getting the most B's that you could get? Given that we know you need 400 A's. right? Maybe 400, maybe are a certain amount of food, right? So we know people need 400 units of food to survive, but then we want to get some bees as well. Are we getting the most bees that we can get, given that we're making 400 eggs? How do you do that? Now, I'm not concerned about how you do that, although you will have to figure that out. I'm concerned about whether how much that is, how many things that is, how many bees you're going to end up with. Question number 8, same idea, except instead, suppose you start out knowing you need 400 bees. What's the maximum number of A's you could end up with if you do it that way? If you do things in an efficient way. These last questions really have to do with more or less figuring out something about what we call the production possibilities curve, although you have to understand the production possibilities to understand production possibilities curve. So is making 300 A's and 950 B's possible? And for that's just yes or no. Even if you don't know what you're doing, just guess because you have a 50-50 chance of getting it right. Question number 10 is making 300 A's and 950 B's efficient? So again, just yes or no. Number 11 is making 300 A's and 1,000 B's if possible. Is that yes or no? By the way, if the answer to number 11 is yes, then for sure the answer to number 9 is yes. Just pointed out to you. Uh, Number 12 is making 300 A's and 1,000 B's efficient. Then, so basically, is it making the most that you can make? So that's yes or no. And then 13 and 14. Let me go through them. 13 and 14 assume that you're making some A and B. Okay, so you got your country, you're making some A and B, and there's prices because none of this has yet, right? Even our talk about cost has to do with the marginal opportunity cost in terms of you're making A, how much B do you have to give up? Well, if we throw some money in, then there's a money cost that's right here. So if you know that every A sells for $1, the question would be then, what's the lowest price that you will find ever anybody willing to sell a B for? So that's question 13. And question 14, if the A still sells for $1, what's the highest price that a B will sell for? And that's a little bit different. Why? The 13 is nobody would be willing to sell you a B. No, if they knew that A is sold for $1, nobody would even make a B unless you pay them enough to make it worthwhile to make a B. On the other hand, if A's sell for $1 and B's are like worth tons and tons and tons of money, it's possible that the B's are so valuable that then you'll have people stop making A, right? So we want to know what's the highest the price of B could be without that happening. Well, A's are still selling for $1. They're still around, and they're still worth $1. So they haven't disappeared. People are still making. Somebody's still making them for $1. What's the highest price that B could sell for? So some of these are just like I said, number 1 through 6 are multiple choice. All you gotta do is just look at the table that you have in front of you, and you can figure out the answer. 7 and 8 involve some numbers, but if you don't like that, then don't just skip those and go on to 9, 10, 11, and 12 are just yes or no questions. You might be able to figure them out. You might not, but even if you can't figure it out, just guess, okay? And then 13 and 14 are probably easier than you think. I'll just leave it like that. But they are asking for numbers, right? They're asking for numerical answers as well. So 7 and 8 are asking for numerical answers. 9, 10, 11, and 12 are asking maybe interpret some numbers. You may have to do a little bit of number crunching there. 13 and 14 are asking you for numbers, but they're probably easier to do than you think. So here's the table, and moving from the table to the answers. All you have to do for the first 6 questions is just interpret the numbers on the table. That's all you got to do. You do have to remember which table to look at for which thing, right? For all of the cost related, you're going to look at the second table. This is the table that if you were on your own, you'd maybe like construct. You may have to construct the table, but you have to figure out what those costs are. The For the just like absolute advantage stuff, then for that you could look at the top table because you just care about how much, how many of the items are being produced. So you're not as interested in cost. So when you do that, here's what you end up with. So which producer has a comparative advantage in making A? So the lowest cost of making A belongs to purple, right? Because 2 Bs is less than 4 and also less than 3. So the answer to the first one is purple, P. The next one is which one has a comparative advantage of making B? The lowest cost of making B is green here because it only costs them 0.25 of an A to make a B. I didn't put that on there, but it's A's, right? And I think that was it was on the sheet that you had, but I forgot to put that on there here. So it only costs 0.25 of an A for green to make a B. That's the lowest cost because that's lower than a third and it's lower than a half. So that's why that's green. Which one has an absolute advantage in making A? Well, there you don't look at the cost, you look at who can make the most A's. So the one who can make the most A is yellow, right? Also, who has an absolute advantage in making B? Well, the one who can have the lowest cost or make the most, that's the absolute advantage, make the most, not lowest cost, but make the most. B is also yellow. Which one would specialize in making A? Now, this is not quite a trick question, but the idea is the one who has the lowest cost is the one who specializes. Now, specialization can either mean if you were like in charge of all 3 of these regions, and you were only going to have only one of the regions make some A, which one would it be? Well, the one you'd have make the A would be the one that has the lowest cost of making A, right? That's how you end up with the most. That's the law of comparative advantage says if you want to end up with the most at the end of everything, if you want to be efficient, in other words, in production, you have to pay attention to opportunity cost or comparative advantage. So the one with the comparative advantage is the one you would ask to make the A first. So that's P. So the answer to number 5 is the same as the answer to number 1. Now, once you answer number 1, you're stuck with an answer to number 5 as well. And then which producer would specialize in making B? Same thing. If you only wanted to make some B, just like you only have one producer make some B, maybe you don't only want a couple of them or whatever, you'd have the lowest cost maker of B make the B, and the lowest cost maker of B is green, right? So you'd have them make the B. Now the next one's trying to figure out how to produce things in an efficient way. Take some math. It's not super hard math, but it is some math. So here's what you got to do. You got to say, all right, if I know I want 400A, how do I get the 400A? And the key to efficiency, the key to getting the most of whatever you're trying to get, like to get the most B given how much A you're getting, is to always pay attention to cost. There's lots of ways of getting stuff without paying attention to cost. For example, if you want 400 A's, you could have like yellow make some A, right? And have green make some A, and then just have the leftovers. Green spend half their time making B, and purple spending all their time making B. But that wouldn't give you the most that you could get. the way you do it to get the most, that was just one example. There's nothing special about that. Or you can have, well, I think, wait, they asked for 400. Yeah, 400. Okay. Um, but there's all kinds of other examples you can work out where you can do it wrong. The only way, in other words, I hate to say it, but the only right way, correct way to do it is to pay attention to cost. So, if you want to get the most, if that's your goal. So, the first producer that you have make any A is going to be the one who has the lowest cost of making A, which we already established is purple, right? Purple can make 100A. So, have them make the 100A. That's all they can make. Then the next lowest cost of making A is yellow. So the next one is yellow that you want to have making any A. And if they make A, they can make 300 total. So if you add together the 100 that purple can make for you and the 300 that yellow can make for you, you got your 400, right? Now, what that means is you don't need any more than that. So you may as well just have green make nothing but B, and in which case you end up with 800B. So the answer to that question is 800. That's the most B you could end up with, assuming that you have the 400A produced in the efficient way. Produced in the efficient way, all that means is you paid attention to cost when you decided who would make what. Now, if you want to make 400B, this is kind of flipping the question around. What is the maximum amount of A that you can make? Well, remember, if you want B made, you first have to have, green make it, right? They're the specialists, if you will, in making B. They have the lowest cost of making B, right? So if you want 400 and you're going to have up here, if you want 400 and you're going to have green make it, well, green can make 800. So that means, you don't need green spending all their resources making B. You can have them spend half their resources making B. And it makes sense to do that because they are the lowest cost. They're the ones you want to have making the B, right? But then they still have half the leftover resources to make, in this case, 100 A's, right? So green can make 400 B's and 100 A. Now the other two producers, all they got to do is make A because you don't need more B. You got it all from green, right? So if purple makes 100 A and yellow makes 100 A, then you'll end up with the 400 B that you need plus the 100 from green, the 100 like leftover, if you will, from green, the 100 that purple's making, and the 300 that yellow's making, and that adds up to a total of 500. Did that make sense? So that's where you have actually some, you have a little bit of math and adding in stuff to do. I'm never going to ask you on an exam or anything a question like that, like either of those two. You are going to have to maybe be able to decide and determine if something's efficient or not. And that kind of is going to require you to do something like number 9. Is making 300A and 950B possible? Now, all you got to do for that one is ask yourself, okay, how do I get 300A if I want 300A? All right, we already kind of figured out how to get 400A, but how do I get 300A if I want 300A? Well, so again, the principle's the same. The lowest cost producer of the A is purple, right? So we got to make sure purple's making some A first, right? So I put down here, just as a little placeholder, purple's making 100A, right? Then the next lowest cost is yellow. In our previous example 7 and 8, we had yellow making all A, but yellow doesn't have to spend all their time making A because we only need, if we want a total of 300, right? We only need 200 from them. So yellow is making 200A. That's what this is saying. Yellow also, though, then has 1/3, because if you go up to their production possibilities, if yellow could make 300A, well, they're only going to make 200, right? They don't. That means 1/3 of their resources are left over, and they can use that 1/3 of the resources to make B. So 1/3 of the amount of B that they can make is going to be 1/3 of 900, which is 300 B. So that's what yellow. That's what P is making 100A. Yellow's making 200A, but then they got enough yellow left over to make 300B. And then green's going to do nothing but make B, because of course they have a comparative advantage of making B anyway, so you want to make sure they're making the B. So when you add it all up, you end up with 300 A's and 1,100 B's. So that would be your total if you're doing everything in the efficient way, right? So if someone comes by and says, "Oh, I figured out a way to make 300A and 950B," is that possible? You say, "Sure, yes, that's possible." So that one is yes. Is making 300A and 950B efficient? Well, it's not efficient. Why? Because if you're making 300A and 950B, and you could be making 1100B, well, that's not efficient, right? You're not making all you can make. Efficient means you're making all you can make. And it matters because, let's suppose that B is shelter. Like maybe A is food and B is shelter. And we need 900 food. I mean, we need, in this case, 300 food for people. But we also want to have as many places for them to live as possible. Well, we only got 950 places for them to live, and we could have had 1,100. So that means some people might be homeless, or they'll have to share or something. So it's not efficient, and that's important for us to know. This is not efficient. It's possible, but it's not efficient. So that's because you can get more. That's the whole thing. Similar question is making 300A and 1,000 be possible? Well, that's also possible, right? Because, hey, you could have gotten 1,100, so certainly making only 1,000 would have been okay. It would have been possible. But it would not be efficient because, again, you're not getting all that you could get. If you could get 1,100, you're only getting 1,000. You're not getting all you could get. Now, 13 and 14 are, even though they're mathematical, they're also actually much easier than they might appear. If A sells for $1, what's the lowest price that a B would sell for? So here's how you do that. Take the cost of a B, and remember, every time you see an A, it's actually $1 because A sells for $1, right? So if one B costs in green, if one B costs 0.25 of $1, we call that 25 cents, right? So all you gotta do is just for every time you see an A in this thing, in this table, on the right side about the cost, just substitute $1. So one B costs 25 cents in green, one B costs 33 cents in yellow, one B costs 50 cents in A. So of all those, which is the lowest price? 25 cents. Of all of those, which is the highest price? 50 cents. So that's where you get the answers to these last two questions. If A sells for $1, what's the lowest price that B can sell for? 25 cents. If A sells for $1, what's the highest price that B would sell for? And that's 50 cents. And again, the reason why that's the highest is because you're told there's still somebody making A and it's selling for $1. So it's not that all the producers, the yellow and the purple and the green, are all making B. Somebody's still got to be making A, which tells us, by the way, at very least, since the lowest cost maker of A is purple's still making some A. And we don't really necessarily care what other producers are making it, but purple might be making some B also, right? It's just not everybody in purple's gone over to making B. Some of them are still making some A. And that's the reason why the purple cost of making an A is what determines that price. If you put all three of the producers we have together, and you can kind of follow along on your sheet there, if you added up all together their production possibilities, you'd end up with 600A if they did nothing but make A together. And then they'd end up with no B if they did that, right? So we're making here a production possibilities table, which you kind of have to do this if you're going to do 3D. Clicker 3D is extra credit. We may or may not do a card on Tuesday on it, but I want you to be prepared if you want to do the extra credit clicker. So you have to kind of prepare this kind of thing. If they did nothing but make A, they can make 600A. But then they wouldn't have any resources left over to make B. If they did nothing but make B, they could make a total of 1900 B, but then they wouldn't have any resources left over to make A. The crucial thing, though, is if you're going to have all three resources and you're going to put them together, you need to put them together in the order that's correct. The order that's correct is, and here you have to kind of keep track of, what we're doing is not making any B at all at the top of the table. And as we go down the table, we want to start making B. Well, green is the first one we have make B because green has the lowest cost of making B, right? Yeah, and there's the individual numbers here that I'm kind of skipping over, but the point is, if you have green make B, the most that green can make is 800B, right? But then you lose the 200 A's that green could have made. So one place on your table that you're going to end up with is you'll have 400 A's and 800 B's, and that's where green's making B, but the other two are still making A. As you move into even making more A than that, then two things happen. Number one, the cost goes up of making B as you make more B, because you're going down the table, we're making more B. We're making less A, making more B. As you make more B, the cost goes up, the price goes up, because now you have to turn to a higher cost producer, which is yellow. And then as you make those numbers in between, if you have yellow and green both making B, remember green's entirely making B, and yellow's kind of, I circled yellow because yellow's kind of switching, right? You can go from 800 all the way up to 1700 because of the 900 B that yellow could turn out if they did nothing but make B, right? So that's another place on the table. If you're right here, the only producer of A still is purple, right? So they're making 100, but the other two producers are making nothing but B. And then as you want to make even more B than that, the price has to go up even higher. That's like the last question. The price is going to go up to like 50 cents per B as you want to make even more B. And as you make more B, as you get more B, as people in the society choose to get more B than 1700, the price goes up, but also they're going to have to start getting some of their B from purple. And the other extreme of the table is where even purple switched into making B, in which case you're at 1900 B and 0A, because everyone's making B instead of A. That kind of table is what you need to do if you want to see how all three of the producers fit together efficiently. And that's what you do for that thing called the production possibilities curve. That's what you need to do. So you have to at least get this far. You don't have to fill out all the numbers in between, but you have to at least get this far to have some idea how the production possibilities curve works. If you graph these numbers, you get the production possibilities curve. So that'll kind of give you a little hint. Notice, by the way, if you graph these numbers, you end up with a graph that looks something like this. Just in general, it has this general shape. If you put A's here and B's here. So anyway, that's just something to look at.